So on lesson 3, problem number 1, I said when you get to a problem like this, I would draw two separate things. So one thing I would do is I would look at the proportional segments that occur between each other. So if we have 4, 5, 6, and x, how do you solve that? Cross multiply and divide. So I'm going to take 5 times 6 and divide by 4. Yeah, that's 30 over 4, but if you reduce it, you should get 15 halves. So don't forget the other part of it, which is the angles. So then I would look at the angles separately, and I would draw that problem separately. And they tell you that this angle measure right here is 81. How many degrees are in that straight line? 180. So what I would do next is I would go through and I would just 180 minus 81 is 99. I would just go and mark every single angle with whatever angle measure value it has. So I know that. Then I would go back and say, okay, what do we have? This value right here of 81 is marked in your book as what? 9z. So if you want to find z, what do you need to do? Divide by 9, so z is equal to 9. And then they also tell you that that other bottom angle there of 99 is the same thing as 3y. So you have to divide by 3. So y is equal to 33. Then you have your answers. I think it's easier if you look at them separate, the angles versus the segments that are proportional to each other. All right, do we run into problems with number 2? Lesson 3, number 2. The volume of the circular cone is 48 pi, so they give you the volume. What is the circumference of the base? They are looking for circumference. So you have this cone here. No, I think it comes up something like that. I think it slants a little bit. They tell you the height here is 9, and they tell you the radius is r. So they want to know what is the circumference, and circumference is 2 pi r. The problem we have is we don't know the radius, so we got to find the radius first. So to find the radius, your volume is 48 pi. Volume of a cone is equal to what? Area of the base, which is pi r squared, times the height, which is 9, then divide by 3. A cone comes to that point, so you have to divide by 3. Now, I would agree what you could do with this is reduce the 9 and the 3. You can do that. What happens if you cannot reduce those two numbers? You could look at it as a fraction and divide by the fraction, which means you invert and multiply. You could put this 48 over 1. It is now a proportion. So you cross multiply. You take 1 times pi r squared times 9, which is just 9 pi r squared. And then you take 3 times 48. So you're going to take 3 times 48 pi. And you set those equal to each other. And then you divide by 9 pi and you solve. Now you can use that as a process. But otherwise, for this one, I think most of you would say 48 pi is equal to pi r squared times the height of 9, and you divide by 3. So you know that 3 goes into 9 3 times. So you get 48 pi equals 3 pi r squared. How are you going to start to solve for r or isolate that? I want to divide by this numerical value in front of r. So you're going to divide by 3 pi. when you divide by 3 pi, the 3 pi's cancel, the pi cancels. What's 48 divided by 3? 16. So we end up with 16 is equal to r squared. And how do you get rid of a square? The square root. Don't divide by 2. Some of you got 8. So you take the square root of 16. That's equal to your radius. So your radius is equal to 4. Some of you stopped there. Some of you said it was 8 because you divided by 2 to get rid of the square. You take the square root. It's 4. Some of you missed it because you stopped there. But what do they ask for? They ask for the circumference of your circle. And circumference is equal to 2 pi r. So you're going to have 2 times pi, and your radius is 4. So you multiply that, and you get 8 pi. Units, meters. Are you seeing where you went wrong? Is there a question? All these formulas, you're doing some geometry stuff. Wow. You love geometry. Number 3. Are we okay with number 3? Yes, nobody needs to see it. Okay, good. Number 4, how are we with number 4? Number 4, I can guarantee you're going to see this on a test sometime, whether it's this year or next year or sometime. Number 4 has a base that looks like this. The figure is the base of a cone. What does that mean if it's a cone? It's going to sit on this, and then is it going to come out straight like that, or is it going to come out to a point? It's going to come out to a point. We have to have a little bit of visualization here because they don't draw it for us. Okay? But this, you take this, and if you were to put paper up on all of those solid lines, then it's extended out, it comes to a point. What do we know about volume of a cone? Yep. Volume of a cone is area of the base times the height, divide by 3. Now remember, that means the same thing as, so you either divide by 3 or multiply by 1/3. The figure of the base of a cone is 10 centimeters tall. So I'm going to take this and I'm going to pull it out 10 centimeters and let it come to that point. The distance from my hand to the board is going to be 10 centimeters. What is the volume of the cone? Dimensions are in centimeters. So the first thing, let's find the area of the base. The area of the base is 2 parts. It is the area of a triangle plus the area of a sector. If I look at the triangle, I have dimensions of 8 and 5. What is the area of your triangle? 20. Base times height divided by 2. So the area of my triangle is 20. I have to add to that the area of a sector. Area of the sector at 60 degrees. It's a 60-degree sector. It's a 60-degree sector. And find the area of a sector. You're going to take the circle and then figure out what fractional part of the circle that is. So it's 60 degrees out of 360, which is 1/6 of a circle. So we calculate pi r squared 60 over 360. The zeros cancel. 6 goes into 36. So you end up with 1/6. Now keep that in mind when you're multiplying those. You can just put it all over 6 because this is a 1 and you multiply fractions by multiplying straight across. So just the area of the base, 5 squared is 25. So you get 25 pi over 6. There's the area of your base. Question. So we're going to take area of the base, which is 20 plus 25 pi over 6. We're going to take that times the height, which is what? 10. And then I could say divide by 3, but then I got fractions within fractions and everything. So what if instead of saying that, I use this multiply by 1/3? 1/3 area of the base times the height. Does the commutative property work for multiplication? Yes, it doesn't matter what way I order or which way I multiply the numbers in, correct? So let's multiply these two together first. What's that give you? 10 over 3. So I'm going to take the area of the base, which is 20, plus 25 pi over 6, and I'm going to multiply by 10/3. That's the same thing as take it times 10 and divide by 3. Use the distributive property. What happens when you distribute? What's 10/3 times 20? So you're taking 20 times 10/3. That is 200 over 3. Then I am taking 25 pi over 6 times 10 over 3. Can I reduce first? 2 goes into 6 3 times. 2 goes into 10 5 times. What's 25 times 5? 125, or 25 quarters is $1.25. 3 times 3 is 9. Don't forget to put your pi, and the units are in centimeters, so it's going to be cubic centimeters. It doesn't go evenly. It would be 2/3 is what you're going to end up with. I suppose if you do that, I mean, it's the same thing. I think it's an extra step, but it's the same thing. How were we with 5? Is a question on that, or can I change the slide? All right. Number 5. Number 5 appears to be confusing when you first glance at it, I am guessing. Anybody struggle with this one? Maybe I don't need to do this one. I don't know. I don't know. If the shapes aren't quite right, that's all right. What we have is something that looks like this. Right? And what they want to know is what is the perimeter of that figure. Now they make it a little more confusing because then they angle off like this, and they're going to angle up over here. Oh, darn it. They're going to angle up over here, and then they angle this one off like something, and then they angle this one off down over here like that. They want to find the perimeter. So what they want to know is they want to know what's the perimeter of that right there. You look at each piece. What's that distance right there? This is 8 right there. Just that distance is 8, right? Because it's the radius of the circle, which means this distance right there is also 8. I think you have another segment that's 8. This radius right there is 8, so I know this distance is 8, and I know this distance is 8. The radius of that top circle is 6. So of course this piece is 6, that piece is 6. And then down here I know that this piece is 5, I think, right? And that piece is 5. They want to know the perimeter. I don't know which way you add it. This is what? 13 and 13, which is 26. This piece is 14 and 14, which is 28. And if you add those together, you get 54. As you look at it, it looks confusing. You're going to say, oh, I've never seen something like that before. I don't know what I'm doing. Read it, break it down, put it into its parts. All right, where we start to get into problems. Lesson set 4, working with a lot of those exponents, I think. One thing I want to point out was on lesson set 4, was number 3 a problem for anybody? You need to just look at what is marked, and you're going to have to cross off some stuff because you really honestly know what to do with this one. They have some equivalent sides equal to each other. This piece equals this piece, and those two pieces are equal. Then they tell you that you have 100 degrees. 100 degrees right there. You have X, Y. First thing you want to do is you just want to focus on just this triangle right here. If these two sides are equal, what do you know about X and Y? They're also equal. You have an isosceles triangle, so those are also equal. If you look at that triangle, you have 100 degrees, so there's 80 degrees left, which means both X and Y would be equal to 40 degrees individually. So now I'm going to do this. Let's erase this right here. And I'm going to erase this right here. And I know that each one of those has a measure of 40 degrees. If that's the case, what do you have right here? A straight angle, which is how many degrees? 180. So if it's 180 degrees and this angle X was 40, then what is P? 140. Everybody okay so far? Now you have this triangle right here. I know I don't have it drawn to scale, but we know that this side right here equals this side here. So what does that tell you about Q and R? They're equal, and if this is 140 degrees, if P is 140 degrees, you have 40 degrees left to split between Q and R. So Q and R are 20 degrees each. Look at those tick marks to help you figure out which angles are equal. You have to find X and Y first. All right, if you have some other questions about the geometry part with those first few questions, come see me. Study hall tomorrow would be good. What I want to look at is I want to definitely look at problem number 14 because I think we start to run into some problems with some of these. There's a system that I would like that I go through. It's not saying you have to go through. And different teachers are going to teach it differently. You could learn it differently. A college professor may show it differently. I don't know. I do not like to start to move negative exponents and make them positive. I do not like doing that. I don't do that until the final step, because if you move this quantity, then students struggle. Do I change all the signs? Do I just change the -2, or do I change the 1 that's associated with the Y? What do I do when I move it? So I choose not to do that if that's the way you were taught, for some of you that have moved in, or if you would rather do it that way, come see me and I will help you do it that way. Otherwise, I see two different things going on here. I see numbers and I see variables. Just like, sorry if you're copying that down, I hope I've copied it down correctly from the book. Remember how we get to this complicated problem like this, and they put it all together in one, and we separated it? I like to do the same thing with this type of problem. Oops. I like to separate just the numbers. If I look at just the numbers, what do you notice about that 3 in the numerator? It's raised to the -2 power, right? So if I look at just the numbers, I have 3, which gets that -2 exponent because it's in the parentheses with the -2 outside. What do you know about the 9? It's also to the -2 power. Now, that's all I want to focus on. For some of you, you get confused when there's numbers there. So we want to do this. Here's what our thought is. Our little thought bubble is that T stands for 3 to the -2 power. N stands for 9 to the -2 power. What do? Flip them. So I'm going to move the 9 up and make it positive, and I'm going to move the 3 down and make it positive. That's all we're going to do here. So 3 to the -2 means 3 squared in the denominator. 9 to the -2 in the denominator means 9 squared in the numerator. I don't care if you calculate those right now or if you show it as 9 times 9 and 3 times 3. 9 squared is 81. 3 squared is 9. And 81/9 reduces down to 9. 9 goes into 81 9 times. Yes. That's part of my answer. 9 is in the numerator. Now what we do is we look at the exponents. Exponents wise, in the numerator, what are we going to have? X to the What do you do when you take a power, you raise it to a power? We multiply because we think of that as being parentheses. Parentheses means multiplication. So 2 times -2 is -4. You have y to the 0, y to the 5th. In the denominator, this y becomes y to the -2. Then you have y squared, and x to the -3rd. Okay, part of the problem is some of you, Taylor, are you studying for your tests? And Jose, are you working on the missing assignments you got? Great. Make sure, like right here, that 2 gets part of that y, and that gets confusing sometimes. Some of you don't make your x's very long right there in that extension, and it kind of looks like a y. The numerator. The numerator is x to the -4th. See, that looked like a y because I started thinking one. So you have x to the -4th and y to the 5th, because now you're adding the exponents. The denominator, you have x to the -3rd, y to the, what do you get? First. -2 plus 1 plus 2 is 1. Now what do we need to do? Move them up, which does what? Changes the sign of the exponent, so you get x to the 3rd, y to the -1st. Now you add them together, which gives you x to the -1st, y to the 4th. And then I put the number part in there, which was 9 in the numerator, or 9/1. Now I go, after I get to that point, then look at how they want your answers. In the numerator, is everything in the numerator? Yes. So here's your answer right here. Question. Okay. Give me a second to write the next one down. I'm going to stop this. Okay. Look at the numbers. What do you notice about the numbers? I'm going to put the numbers over here. Okay, if we look at the numbers, I just have a 2, but this 2, here's the only number I have. The rest are variables. That 2 is being raised to this power, right? So as I calculate it, I'm going to have 2 to the negative 2, which has a value of what? 1/4. 2 squared is 4, put it in the denominator. So my answer will have a 4 in the denominator. If I look at what they asked me to do, it says express everything in the numerator. We don't write that answer as 4 to the negative first. It says write all exponential expressions in the numerator. That's your variables. The variables is what goes into the numerator. So far in my answer, I'll put it over here, we're going to have a 4 in the denominator. Now let's look at the variables. If I look at the variables, y x to the negative second is being raised to that negative 2 power, which means y to the negative second, x to the fourth, negative 2 times negative 2 is positive 4. Then you have y x squared. And the denominator, what happens right here? It's the number 1, or it is x to the 0 power, because anything times 0 is 0. It is going to be the number 1. Okay, some of you do that. You look at that and you say that's the number 1, so you're going to put a 1 in the denominator. You multiply those two numbers together, don't add them. Some of you want to put that as a 1 and then change that 4 to a 5. You're multiplying them, okay? All right, come back over here. We have y to the negative third and x squared. So the numerator, that's going to give you y to what power? Negative first, negative 2 plus 1. Now I'm adding the exponents. So negative 2 plus 1 is negative 1. X to the 4 plus 2 is 6. In the denominator, 0 plus 2 means x squared, and y to the negative third. Now what do? Move them up, which changes the sign of the exponent. So it's x to the negative second, y to the positive third. And if I add those exponents, we get x to what power? Fourth, and y to the second. So I'm going to put that in my answer over here, x to the fourth, y to the second. And as I mentioned, you're going to take 1 times 4, which is just going to be 4. My variables are in the x, or in the numerator, so we just write our answer that way. Now you have to be careful if you're choosing to write it as 1/4 x to the fourth y squared. Please do not show that on the lines of your paper and do this, because I will count it wrong. Because right there, what's being multiplied by x to the fourth and y squared is 4. This x to the fourth y squared is ending up in the denominator. That's incorrect. So please do not show it this way, because I'm going to count it wrong. Make sure I can see those variables in the numerator. Are you finding what you're doing wrong? Yes or no? I want to look at number 18 and just the the number part of it. In number 18, you have a 3. I don't know, I guess copy the whole problem down. X squared x. And if I don't write the whole problem down, some people might get confused. In the denominator, you have x squared y to the negative second. And then you have the value of negative 2 to the negative 2 power. I just want to look at the numbers to come up with what I'm going to have for an answer for numbers. I have a 3 in the numerator, and then in the denominator I have this value. So if we pull those out separately and look at it, I have 3 over negative 2 to the negative 2 power. What does that mean? The 3 is not going to change positions, is it? What is negative 2 squared? 4, positive 4. What does this negative exponent mean? Move it to the top. When you move that 4 to the numerator, what do you do to those two values? Multiply. Don't add them. You multiply them. Now, if you want to look at it differently, you could say 3 over negative t to the negative 2 power. If I move it up, it becomes 3. If I move it up, you're going to get negative t to the positive 2 power. What sign changes is the exponent. A negative squared is a positive. Negative 2 times negative 2 is 4. Multiply those two together, and the number part of your answer is going to be a 12 in the numerator. Variable-wise, in the numerator, you get x to what power? 4, 5, 6, 7, x to the 7th, and y to the 2nd. In the denominator, you get x to the negative 4, y to the negative 2nd. Then you need to move them up and change the sign of the exponent. X to the 4th, y squared. And you end up with x to the 11th, y to the 4th. I hope I copied the problem correctly. My bad. I did not copy correctly. I missed something, and what I missed was right here. This is a negative 4 in the problem. Sorry about that. So please correct it, which makes the x exponent what? I should have checked it closer, sorry. In the numerator, you have negative 4, 1, and 2, which makes it to the negative first. So if I group these together, I get negative 1. Negative 1 plus 4 is 3. So it should be 12x cubed y to the 4th. Please correct that, because I missed that negative sign right there.